Hello. This lesson is entitled 1D Motion Problems 2. In previous lessons, we went through the concepts of velocity and acceleration. The equations for these quantities are shown here. Now, we'll practice using these equations, and we'll be introduced to Dr. John Scott's guess method of solving problems. So here's a problem that we need to solve, and we're going to solve it by guessing. Guess is an acronym where the G stands for the given variables, which are the variables that you know the quantity for. U stands for the unknown variable, which is what we're looking for. E stands for equation, which is the equation that relates the givens and the unknowns. The first S stands for solve the equation for the unknown quantity, and the second S stands for substitute quantities into that equation and solve your problem. So, if we read through this problem, an arrow is accelerated by a bowstring to 36 meters per second in 0.31 seconds. Find the arrow's acceleration. After some amount of thought, we can realize that the final speed of the arrow must be 36 meters per second. The time over which the acceleration takes place is 0.31 seconds, and the unknown is the acceleration. So we look through our equations, and we haven't seen very many, and we want to find the one that relates these quantities. So the definition for acceleration is change in velocity over change in time. So I'm going to check off the variables that I know. I know the final speed, I know the time, and I'm looking for the acceleration. However, you can see that I can't use this equation because I haven't identified an initial speed or a change in speed. So now we have to think, wait a minute, the arrow will start from rest, so I do know the initial speed. It's hidden in the equation, or it's hidden in the problem. It's just not out there for us to see clearly right from the get-go. In other words, we don't say it, but it's implied. Now we're ready to go. I'm going to just forget that part of the equation, and I'm just going to use the rightmost portion of this. So the first S stands for solve the equation for the variable we're looking for, which is pretty much already done, and the last S stands for substitute the values. The final speed, there's your initial speed, there's your time, 120 meters per second squared. Technically that's just the magnitude of the acceleration. We don't have any idea about direction, but that's good enough for now. Let's try another one. A car is traveling 65 meters per second and approaches a stop sign. So that means that the initial speed of the car is 65 meters per second. It says that the driver applies the brakes for 8.2 seconds. Well, 8.2 seconds is clearly a time, and we want to find the car's acceleration. So the unknown is the acceleration. We're going to use the same equation as before to relate these quantities. Again, I'm going to go ahead and check off the ones that I know. I know the initial speed, I know the time, I'm looking for the acceleration, and here again we find that we're at a bit of a standstill for a moment, because in order to use this equation to calculate the acceleration, we need to know every quantity here or every quantity there. So let's think a minute. This car is approaching a stop sign, so the final speed will be 0. Now I'm ready to cross off that portion of the equation, solve the equation for the variable I'm looking for, substitute the numbers in. Remember, the numerator will be final minus initial speed, and that's going to give us a negative number, negative 7.9 meters per second squared. And that just means that the velocity gets 9.7 meters per second less positive each second for 8.2 seconds. So initially the car was traveling 65 meters per second. 1 second later it's going 7.9 meters per second less positive, or 7.9 meters per second slower than each second before, and it does that for 8.2 seconds. If this problem is simply repeated, but instead of applying brakes for 8.2 seconds, the car slams into a tree and stops in this amount of time, the change in velocity is the same. It starts out at 65 meters per second and it ends at 0, but the time is much, much smaller. And you know that if you divide by a very small quantity, you end up with a very large quantity. And that amount of acceleration can't be handled safely by the human body. It's not speed that kills, it's the rate of change of speed, acceleration, that kills. Please don't be stupid. Thanks for joining me.